In this lesson, we're going to take our first look at the JAX RS framework. JAX RS, again, stands for Java API for XML, RESTful Services. It's become very popular in the past few years, and there are various implementations. I'll talk about those in a bit. To begin, we're going to look at one of the working files. This is called JAX RS overview.txt, and it shows how JAX RS differs from the straight servlet implementation we considered earlier. The basic difference you can see in this little depiction. So a client request comes in, and it hits a specially provided JAX RS servlet. This servlet is designed precisely for a web server such as Tomcat or Jetty. The JAX RS servlet then takes the incoming request and dispatches it to the application. And this application I'm going to call Predictions 3. The same point could be made more technically. What you're looking at here, and I'm going to highlight something in roughly the middle of the screen, you're looking at the web.xml configuration file that is used for the Predictions 3 service. And the line you see, servlet class is the XML tag, specifies com.sun.jersey, blah, 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 .servlet container as the servlet to hit. In other words, this is the official name for this JAX RS servlet up above. This pattern is sometimes described as the interceptor pattern. So a request goes to a servlet. The servlet then passes off the request to the appropriate application. And we'll look at this in some detail a bit later. I'd like to highlight now another feature. The Predictions 3 WAR file, which is available in the working files, has a lot of embedded jar files. Those jar files represent software libraries, and they bring up an interesting issue in doing web services. So as I've depicted the issue here, I call it to freeze or not to freeze the WAR file. So let me explain the difference. Freezing the WAR file means taking all of those jar files and embedding them inside the deployed WAR file. The main point for doing this is to avoid any sort of dependency issues, in particular, any sort of version control issues. The downside of this approach is that it makes the WAR file a little bit bigger because you've got these nested jar files. The alternative is to take those jar files and to copy them, for example, in the case of Tomcat, into Tomcat home/lib. That's where Tomcat libraries are stored. They're all jar files. If you take that approach, you have to restart Tomcat. The good news here is that those jar files would be shared across applications. I must say that my own preference is for the freezing. This makes production level deployment much easier. I can, for example, develop on one machine, take the WAR file, move it to a staging machine, move it from the staging machine to the production machine, and all of the dependencies are inside the WAR file. So I must say I like this approach quite a bit. Now, there are various JAX RS implementations. We're going to use one called Jersey. It's the reference implementation. You can see I've provided the URL at the end. It's a good implementation, but there are other good implementations as well. Before wrapping up, what I'd like to do now is to run a little test. Again, I'm going to use a Perl script, and this Perl script is quite similar to the previous one. Let me bring up a terminal window here on my Mac. This is called curls test rs.pl, and it's going to illustrate some of the functionality in the Predictions 3 service. So let's give it a run and hope all goes well. The first sample curl request I'm showing is a request for XML. This is at the end of the URL. So basically what I'm asking for here is an XML document that represents prediction 12. I hit return, and you can see I've not formatted the XML in any particular way. It is basically the way it's delivered, no indentation and so forth, but you can recognize one of the predictions. The next one is I'm going to ask for XML/foo this should not work because I expect a number at the end, and foo is quite definitely not that. And what I get back is a long error message. Basically, the gist of it is right here, HTTP status 404 not found. So my application rejects this. In a bit, we'll see how it does that. Now I'm going to ask for all of the predictions, but in JSON. This is quite a screen full. We don't want to try to read this. No indentation, but just by eyeballing it, you can see that we're getting back all of the predictions. Then finally, we're going to do the same thing, but we're going to request plain text. So you can see that in the curl URL. And here we get them nicely numbered. I'm going to use the plain text quite a bit because it's easy to confirm that creations of new predictions, editing of existing predictions, and so forth have worked. So to that end, we're going to do a post request, add a new prediction. We get a confirmation that that's been done. Just to be sure, we basically ask to see them all yet again. And as you can see down at the bottom, prediction 33, this is the one that was just added. Now we're going to delete that. This is the curl URL up at that first line, and we get a confirmation that it's been done. Just to be sure, we're going to look at all of them yet again. And as you can confirm down here at the bottom, the last prediction is number 32. It's that familiar prediction by now from Hiram. So the Predictions 3 service, like the Predictions 2 service, supports all of the CRUD verbs, but it's a little richer in its data typing. The response document can be JSON, XML, or plain text, and we have a slightly different form of requesting URLs.